Today we'll be working on the following problem. We want to construct a sequence of continuous functions f sub n on 0, 1 such that f sub n is between 0 and 1. And the limit of the integral of fn over 0, 1 goes to 0 as n goes to infinity. And the sequence f sub n of x diverges for any x in 0, 1. Okay, pause the video if you want to work on this problem by yourself. Okay, let's see what is our solution. So let's think about this. We want to find this, first off, this sequence has to be convergent, divergent, right? So for divergent sequence, like, so let x sub 0 is in 0, 1. If we can construct a f sub n in such a way, this sequence contains infinitely many two different values. Let's pick like a 0 and 1, right? If we can find this, then it's convergent. Of course, we also want like the integral goes to 0 as well. So as we know, like we can use this for any n natural number, there exists unique k and I such that n can be written as the format of 2 to the power of k plus I, where I is between 2 to the k minus 1 and 0, right? So let's use this fact. So then if we say this from 0 to 1, for any given k, we can divide this interval from 0 to 1 into 1 over into 2 to the k parts. So each part is 1 over 2 to the k. So if we see something like this, let's see, we pick a typical one. Let's go with like a j over 2 to the k here, and then j plus 1 over 2 to the k here. This is j plus 2 over 2 to the k, and then here is j minus 1 over 2 to the k, right? So this is y, and then this is 1. So let's make a function like this. So here, from j over 2 to the k, j plus 1 over 2 to the k, this, we make it the value equal to 1. And then this part, we make it 0. And this part also 0. So in between, we make it linear. So because we require this f sub n has to be continuous, right? So this is a continuous function from here, like this, a continuous function. So in this case, basically what we are saying is like for 2 to the k plus j, n equal to 2 to the k plus j, this f of x is in this format. I'm not going to write down because you can see like you can make it in a closed form, right? What is this? But from the picture, it's easy to see what kind of f sub n is, right? So now here, of course, like j, we want j from 1 to 2 to the k minus 2, right? So 2 to the k minus 2. This part is at most and one part. So now the edge case, like what happened if j equal to 0, which means like n is 2 to the k case. So in this case, we want to do something like this over, you know, here is 1 over 2 to the k, right? 2 over 2 to the k all the way. So here we can, and here this is 1. Here we want to make this part from 0 to 1 over 2k to be 1. And then from 2 to the over 2k to 1 to be 0. And then this part is linear. So this is the format when, you know, n equals 2 to the k. This format, right? So the graph of this like this. So now what happened with in this part when you know f n equal to 2 to the k plus 2 to the k minus 1, right? Basically here. So do similarly we can find okay, this is 1, so this is 2 to the k minus 1 over 2 to the k. Here is 2 to the k minus 2 over 2 to the k, right? So we can make here is 1. So from 2 to the k minus 1 over 2k to 1, we make it 1 here. So the f of x is equal to 1. And this part from 0 to 2 to the k minus 2 over 2 to the k, f of x is 0. And then in between we make it linear, right? So that the function is continuous. So if you look at the you know, f of sub n like this, then it is clear to see like you know, clearly for any fixed x sub 0, and then if we look at the sequence, because f x sub 0 for any k is in one of the intervals, right, from j to this, but then your j varies from you know, 0 to 2 to the k minus 1, and then your k increases, and then for any this, so you can see this one has infinitely many 0 and 1s, right? Infinite many. So for any x sub n in 0, 1, which means this f sub n of x and x 0 is diverges, right? You have infinite many along the way as n goes to infinity. Now we check whether this one, of course, this is between 0 and 1, because we require it's between 0 and 1. And now let's check the integral, right? So which from the construction, this integral is at the you know, if you look at this, is just the area of this, right? So and with length this, it at the most, what is the interval of this? This is you have a base is 1 over 2 to the k, and then times the height is 1, and then you add this two together. It's at most 2 of them, right? 2 of this. And then from n is, because okay, n is what, and any n can be written in this format, so n is less than 2 times 2 to the k, right? So but it's bigger than 2 times k, so this is at most we make it even more room, so 4 over 2 to the n. This goes to 0 as n goes to infinity. So yeah, that's it. So we have construct such f sub n.